Hello, this is Peter from OneCNC UK, and in this video we're going to take a look into just some of the main advantages of upgrading your software from Professional to XR9 Expert. On the home screen, the only difference you'll see is the icon for Pages. This gives you the very powerful ability of creating a 2D drawing directly from the 3D model. These views can either be wireframe, solid, or a combination of both. This is just a very quick overview on Pages, as there is a video that goes into this in a lot more detail. If you are interested in the Pages, please contact us at OneCNC UK and we will be happy to send you the link. The main difference in the Expert version is the ability to cut to a stock model, which is available in both the 2D high-speed pocketing options and also in the 3D Z-level roughing cycles. And along with the 19 extra toolpaths within inside the model toolpaths, 4 in the roughing and 15 in the finish. So let's have a look at just some of the options that are available, which will help dramatically reduce cycle time, which in turn gives your machine more capacity, and also improve the surface finish on your 3D components using one of the many surface finishing options available. So we'll start with machining to stock. This gives the ability to create a toolpath, then compare that toolpath back to a solid model. It will then in turn eliminate the fresh air cutting, giving you a much more efficient toolpath and dramatically reducing the cycle time. So we'll just minimize the Mill Professional screen, expand the Expert and just reopen the toolbar on the right. So in this example, as I say, we're going to look at machining from stock. In this example, our model is exactly the same as the stock model, the only difference being the stock model hasn't got the pockets in. I've already extracted the edges from the base of the pocket, so we'll go right ahead and create ourselves a toolpath. So we're going to go to stock toolpaths, high speed pocketing. I'm just going to select the first 2 pockets. Obviously, in reality, we would select them all. I'm quite happy with the tool selection, speeds and feeds. I'm quite happy with the depths. We're working with a closed boundary. For this example, we're not working from stock. I'm going to ramp helix entry. Quite happy with the step over and the roughing depths. And we'll simply select finished. And there is our first toolpath. And if I just view that from the left-hand side, obviously the way the pocket machining works in 2D, it's removed all of this material that doesn't really exist. So this is where stock comes in. Now, just before we go into stock, we'll just very quickly have a look at the cycle time. So we'll just go into our job sheets. And as you can see, cycle time 31 minutes. So we'll now recalculate this toolpath using stock. So I'm going to go to edit. I'm going to leave the speeds and feeds exactly as they are. And when we come to machine from stock, we're going to actually select the layer that the stock on. Now, even though you have to simulate to a stock layer, the model that you're comparing back to can be on any layer that you'd like, casting layer, pre-machined layer, but as it happens, this is in our stock layer. We'll just accept that form, leaving all the defaults the same. Again, we'll view that from the left-hand side, and right away you can see it has eliminated all the fresh air cutting. So when we now check our cycle time, you can see straight away we've eliminated at least 12 minutes on just those two pockets. So the time saving is obviously a major fact in this particular toolpath. This is also available, as I say, if you're doing 3D machining using Z-level rough. So what we'll have a look at now are a few new toolpaths available in Expert for finishing. These do not require boundaries. They work purely by surface selection and guide rails. So we'll just open up our model toolpaths. We've already put a Z-level roughing cycle down there just so we can simulate. And we'll start having a look at flow machining. When you select flow machining, it asks you to select the surfaces. You simply left-hand mouse click on the surfaces that you want to machine. It doesn't matter in which order you do these, and if you do make a mistake, you simply left-hand mouse to remove it. Once you've selected the surfaces, right-hand mouse click, and then it's a question of selecting the guide rail and right click to end. I'm quite happy with the tool selection, the clearance form, and as you can see, when you're looking at guide rails, depending on the surfaces you're trying to machine, you can even select a single guide rail or two guide rails. And then you can either work away from the guides or towards the guides. I'm going to work away from the guide for this one and finish. And there we have it. So if we just put this into backplot, we'll zoom in, and I put quite a large cusp. I put 0.2 step over in, and that is purely so you can see the new cusp control available within the software. The surface finishes are far superior. We've got steep and we've got shallow surfaces all involved in the same toolpath, and you can see the distance between all of those cut paths is identical. So it's a very quick and efficient way of creating an extremely smooth toolpath. So I'll have a look at doing a couple of other surfaces. Again, we'll go back into flow machining. We'll select the surfaces that we want to machine. Again, right click to end. Select your guide rail. I'm just going to push it into that corner and right click again. Again, I'm just going to select all the defaults and finish. So we'll just do a few more. We'll go back to flow machining. We'll just select those simple surfaces there. Again, give it a guide rail and accept the form all the way to the end. Again, we'll just select the surfaces, select the guide rail on top, and just accept that form all the way through. So as you can see, it's a very quick and simple method of finish machining and keeping the toolpath control in line with the actual surfaces that you're machining. And we'll just do one more. And give it a guide rail along the top. Select the form all the way through. As you can see, this is quite a complex series of curves going into this upstand, and you'll notice there are very little lifts as it gets there. So let's have a look at planar finish. So again, with planar finish face, it's just a question of selecting the either single or multiple faces. I'm just going to go with one for this one. We'll leave the tool exactly as it is. We'll give it an angle of 0, and again, finished. I'm going to do one more planar finish. Just simply left-hand mouse click, and we'll accept that form all the way to the end. So there we have flow machining and planar finish. And one other toolpath that doesn't require boundaries is area machining. So again, it's a very simple method of creating toolpaths without the need for complex boundaries. You just simply select all the surfaces that you want to cut and right-hand mouse click. Again, I'll stay with the same tool. Quite happy with the clearance form. Point one step over. You can either spiral inwards or outwards and finish. Okay, so let's just drop it into simulation and we'll have a look at some of these toolpaths. We're simulating to a stock model. As I say, this is just a standard Z-level roughing with a reducing step back to give me a slightly better surface finish to go over with the finish tools. And we'll just get ready to slow it down. And we have our first flow machine. I will fast forward this every so often so you don't have to sit there watching the entire toolpath. But these are very brief explanations of these flow machining, planar finish and area machining. If you are interested in anything that you see in this video, please contact us at OneCNC UK and we'll be happy to send you a link or more information. As you can see, this section is now a vertical section, and generally in planar it would just drop down and miss. This now has perfect cost control. Here we have the planar finish. Again, without the use of boundaries. I've just picked flat surfaces for this one, but obviously they can be tapered as always. Just about to finish off is the area machining. Minimal lifts, full directional control, purely by using surface selection. A very quick, simple and efficient method of programming. And apart from that one surface that was just flow machining again, job done. Very quick, very efficient. In this section of the video, we're going to concentrate on valley machining. Valley machining is a quick and easy way of either creating standard fillets or variable fillets in the base of a pocket or around an upstand. Expert also has the ability of pencil trace, which again is a filleting operation. The difference being is pencil trace, for example, a 2mm fillet can be machined with a 4mm bull nose. Valley machining allows you to generate the fillet radius with a smaller tool. All you need to know is the largest radius in the base of the pocket. So we're just going to go up to my verification tools and left click. And as you can see, we have a common fillet radius of 7mm. The only other thing you need in this particular example is a simple boundary, or you can create 3 fillets in the same toolpath. We're just going to do one for this. So we're going to go into valley machining. I'm quite happy with the size of the tool and the clearance forms. The largest fillet radius, as I said, is 7mm. We'll give it a 0.2 step over. We'll tell it to do 20 step overs. And next. We're using a pick boundary and finished. We then simply select the boundary and right click to end. And there we have a very quick and simple filleting operation. So you can see the tool path a little bit easier. We'll do an upstand. Again, the first thing you need to know is the largest radius. So we're going to go into my filleting options. We're just going to verify, and we have a 5mm standard fillet. Again, we're going to go into valley machining. Quite happy with the same tool. Quite happy with the clearance forms. We've got the largest radius set to 7. We'll leave the 0.2 in there. We'll say do 25 steps on this one. And next. We'll use a extents box for this one. So we'll just recalculate the extents box and finish. As you can see, very quick and simple filleting operation. So we'll just preview this toolpath. And as you can see, it's a very quick and simple toolpath to generate either single or multiple radiuses. Obviously, depending on the surface finish, depends on the amount of step overs you put in. Again, this is a very quick video just to show you the different toolpaths that are available. If you do have any further questions, please don't hesitate to contact us at OneCNC.co.uk. And just to end this video, we'll take a look at deburr. Now, deburr is not a chamfering cycle. Deburr is exactly what it says. It's just a quick deburr operation to break the edge with a small ball and mill. This can be used in either 3, 4 or 5 axis positional modes. So we'll go down into model toolpaths. We're going to select deburr. We're going to select ourselves a tool from the library. We'll just go, as I say, with a small ball end mill for this one. Numbers, speeds and feeds. Rapid clearance and plunge clearance. And the deburr amount, as I say, depending on the size of the ball end mill, depends on the maximum burr amount allowed. So I'd be quite happy with a 0.2 deburr on this. And if I want to deburr everything, I could work to either extent box, boundaries, part boundaries, or selected edges. So in this one, we'll just do part boundary. Just recalculate the part boundary, just to be on the safe side, and select finished. And it will run a deburr cycle around everything it can see within inside that boundary. Now, you might not want to machine everything on there or deburr everything on there. So another option is select. So what we'll do is we'll just go into deburr and we'll edit. We'll just accept this form to the end. We'll swap over to picked for this one, selected edges, and finished. And then all we need to do is select maybe the angled holes on the front face, maybe the holes on the bosses, and it could be we just want to run a deburring cycle around those tiny little upstands and that flange in the middle. And when you right click, it will simply deburr those picked sections. We'll just preview this through. It's a very, very quick and efficient way of just creating very small break edges on any shape or profile, rather than having the operators spend time with a scraper. This way it is standard on all components. Well, I hope you've enjoyed this video. As I said, there are many more options available with Inside Expert, and if anybody has any questions whatsoever and would like a more detailed video, please do get in contact with us at OneCNC UK, and we'll be happy to send you the links over. Goodbye.